This is the Tormach SuperFly. It's a fly cutter, but it also is good for a lot of material removal. Carbide insert, about a 3-inch diameter. I really like it, but I'd like to have something a bit bigger than this. A 3-inch diameter is limiting to me sometimes. So, I made the SuperDuperFly. I actually purchased the fly cutting bar from Suburban Tool, link below, and then I made the body for it with the Tormach tooling system style shank. So let's go over how that happened. What I've done is I purchased from Suburban Tool this bar, this fly cutter bar. It's very heavy duty, very substantial. It's made to use in a large mill, do some serious fly cutting. They make these in, this is a 5-inch, they make a 7 and a 9-inch, I believe. People use them for fly cutting heads on engines, that sort of stuff. But I'm going to pretty much use this as small as I can go, and I'll make my own arbor for it because they don't offer a TTS arbor, probably for a very good reason. This fly cutter is pretty heavy and it has a lot of rotational energy. If you put it out, you get a lot of radius to it and then start spinning it very fast, this collar, the collet that holds this won't be able to secure it very well. It could be very dangerous. So there's no way I think Tormach would want to make a product like this that goes in TTS. So maybe not the smartest thing to do here, but I'll be the only one using this, and I plan on keeping the RPMs really low and doing some other things to make it as inherently safe as it can be. Whenever I do dangerous things, I try and do them as safely as possible. But that's my project for today, make a larger version of the SuperFly that I'm calling the SuperDuperFly. So, as I said, to that extent, I purchased the Suburban Tools fly cutting bar, and then I got some inserts for it, although, to be honest, these carbide inserts last so long I may never get past the first one. And then I have this giant chunk of 3-inch diameter by 5-inch long steel. It's a 12L14, which is really free machining, sort of turns really well in the lathe. So I've got that, and that's what's going to form the bigger version of this arbor. So you can see that there's a whole lot of space in there. I'll be chunking some stuff off. My little clousing lathe that has a small chuck on it, and it's not quite big enough to do the 3-inch diameter. In fact, I hate to admit it, but in trying to chuck this up, it barely fit, and then trying to tighten down on the, using the inside jaws, trying to tighten down, I broke the gear off one of the number 1 jaw. So now instead of being able to safely hold 2 3/4 inches, my chuck only holds 2.5 inch stock. I really need a bigger chuck, or it'd be nice if that chuck came with some outside jaws instead of just the inside jaws. So I'll be upgrading my jaws later, but for now, what I'm going to do is machine this. First I'm going to, these are just rough cut ends, so I'm going to flatten the end, make it normal surface perpendicular to the sides of this, and a little bit of irony, I'm going to be using the SuperFly to fly cut the top to remove that material. So the SuperFly will help build the SuperDuperFly. And then I'm going to pocket the end, and then I will use the outside part of the inside jaws on my chuck to, instead of grabbing the outside, I'll be grabbing the inside pulling out, so that my little chuck on my lathe can hold this piece of stock. And this is a pretty heavy piece of stock, so I'll need something pretty secure, and I won't be putting a whole lot of force into it. I'll be making light cuts so this doesn't get away from me. Low RPMs, I'm not used to turning stuff this big, so I'm going to go conservative on all that. So let's get started with it. I'll be back and we'll be doing some stuff. Well, you just saw the very last pass boring, and it is boring. I get the feeling a lot of machinists just watch this kind of like people watch NASCAR. They're just hoping to see a crash. I also think that serious machinists probably watch this and think, I can't believe that worked. But anyway, shout out to Jim over at Mesa Tool. This is the inaugural use of the new Mesa Tool boring bar, which replaced the import craptastic boring bars, and man, it works great. Carbide insert tooling is just awesome, and it's real solid, rigid, beautiful finish. Well, we're getting a little closer now. The diameter is much smaller, so I'm taking a heavier cut. I'm taking 50 thousandths cuts here toward the end. Makes a hell of a chip. One long continuous chip comes out of there, like 15 feet long or something. Making some monster chips. I think this is my personal record here. It's a 19-foot long chip. Don't know what to do with that. Pitching the trap again. Well, the lathe work is just about done, I think. I've done the Tormach tooling system in there. I'll turn it down to 3/4 of an inch, chamfer the end, and then there's this geometry up in here. That's where the Tormach tooling system captures the tool in a modified R8 collet. So the R8 collet, the R8 collet goes up in there, and then when you tighten it up to pull it up into there, the collet grabs and pulls up, but the part that indexes is this ring right there. So it's this narrow ring, that's what catches the spindle, controls the Z height, and that width is what gives you all that stability that holds it. So it's being held on the collet, but that's mostly pulling up. Most of the actual force that opposes the rotation, all this friction there, and the upward pull of the collet. So that's what holds it. It's being held here and here. It makes it a little, that's here and here. It makes it a little more secure than if it was just being held in an R8 collet spinning around. It could torque and spin out a lot more easily. So anyway, I've created the same geometry there more or less. It's very slightly different based on the tooling I had. I had to use one of these cheap Chinese boring bars, made using a boring head, but that's what created some of that geometry in there. And I went very slowly and made sure it didn't crash anything. But anyway, now I'm stuck needing to part this off, and I don't have any parting tools that'll go 3 inches. Most of the stuff I part off is 1 inch or so. I might have some old stuff around here, but I think what I'll do is take this over to the bandsaw. I've got a horizontal bandsaw, and then I'll chop it off the length I need. Well, before heading over to the bandsaw, I decided to use the parting tool to put a little groove in there that I call bandsaw helper. This will help the bandsaw blade stay in the cut and get a good start, keep it running straight. So hopefully I won't have too much waste material to remove. I did cut it 1/10 of an inch longer than I wanted it, or needed it to be. So this is sort of how it's going to go. Like right in there. So, off to the bandsaw. Well, my bandsaw wasn't able to hold this piece of material, so rather than engineer something, I just came back to the lathe and decided to hacksaw this thing off. It's not as dangerous as it looks, but it's every bit as stupid as it looks. This is like chapter 180 in the book of why all these little projects take longer than I think. Like sands through the hourglass, so are the days of our lives. Okay, now we're really finished on the lathe. Decided to go ahead and face it off to the correct length. So this is 1.5 inches now, which is 1 inch for the fly cutting bar, and 1/2 inch of material behind it to support it, and chamfered the edge. And as nice as the fly cutter is for making a surface finish, it's still not as nice as my lathe doing facing work. And it's also faster on the lathe. And the setup is much easier on the lathe. So decided to do that on the lathe. I started off on the mill. I'm finding myself doing more and more on the lathe just because setups are easier, and I don't know, it's kind of more fun. Well, I'm using the SuperFly now to produce the 2 flats on both sides. So the bar will go in through here. There'll be a slot in here that I flatted top and bottom. So I'm going to put some screws in there, and also just to reduce the rotating mass. I'm going 12.5 thousandths depth of cut at about 60 inches per minute and approximately 1,000 RPM. So several passes like that, and I'll have it down to 2.5 inches here, or excuse me, 2 inches here, which will be a 1 inch bar, and 1/2 inch on either side. Well, I've finished putting the flats on the top and bottom here. They're centered on the 3/4 inch shank. I used the SuperFly to do that. Now I'm going to put a 1 inch wide, 1 inch deep slot in here for the bar, and then drill and tap 3 holes for set screws, and it'll be finished. First pass with a 1 inch high speed steel end mill. So I'm making the slot for the bar. That was the final pass. 1 inch wide, 1 inch deep slot. I was going 25 thousandths depth of cut, about 6 inches per minute. I'm probably going to run one more little finishing pass in there to clean it up. I did hear some chip recutting. I had some air on it there, so I'm trying to keep the chips from getting recut. They blew the hot chips into my hands, so I quit doing that. But overall, it's a nice surface finish. That 12L14 does machine nicely. Well, as you can see, we're all finished. I drilled and tapped 3 holes here. These are 3/8 by 16 set screws. They're 5/8 of an inch long. The center one is in the center, and then the others are 9/10 off center, just to keep them on the flat, but get them as far apart as possible. That holds the bar really securely. So there's the bottom, there's the carbide cutter that does all the work. You can see how it all turned out. Turned out pretty nicely, I think. So we'll go ahead and get this installed into the spindle, and then I'm going to machine this piece of A36 steel. It's hot rolled, doesn't machine nearly as well as the 12L14 steel I used to make the tool here, but this is going to be the block for my lathe gang tooling. So we'll go ahead and show you how it works. Well, that was 350 RPMs at 10 thousandths depth of cut and about 1 inch per minute feed rate. I slowed down a bit there at the end when it was making that double interrupted cut where it was just cutting the two corners. Harmonics are a big problem with a non-rigid mill like this. Once it starts shaking, it's all over, so need to stay out of the harmonic areas. And those interrupted cuts are murder for that. You can tell, though, it's making a really nice dark blue chip, which indicates there's a lot of heat going into the chip. They certainly felt hot when they were hitting on my arm. There's an example of the surface finish, though. I could get probably a better surface finish. It feels really smooth, but I could get a more optical type surface finish if I went to a higher RPM, but I'm a little skittish about going to higher RPM right now until I get a little more experience with it. But so far it seems fine. That was 6061 T6 aluminum, 350 RPMs, about 1 inch a minute, and 20 thousandths depth of cut. Surface finish is quite nice. Maybe not quite as nice as it could be. I think I'll switch out the cutter, that carbide insert that was hogging through all that scale on the outside of the hot rolled steel. Put in a sharp new uncoated carbide bit, and then maybe crank it up to 500 RPMs and take a shallower cut and see what happens. That was 500 RPMs, 5 thousandths depth of cut, and about 2 inches per minute feed rate. And that's a pretty nice finish. A slight ridge to it. It's nice and flat, but it does have a slight surface ridge to it that higher RPMs or slower feed rate would surely fix. But that was Kind of a nice compromise there between feed rate and material removal versus surface finish. Overall, I'm rather pleased with it. I hope this has given you the encouragement to either buy or build your own larger fly cutter. Really nice to have. Anyway, enjoy your machining, be safe, and I'll see you in the next video.